Okay, here we have problem 15 on page 548, and this one has to do with morphine. It's a pain-relieving drug, and we're given a half-life, which is 2 hours. Morphine can be administered intravenously at a rate of 2.5 milligrams per hour, and we're told that the rate at which it is eliminated is proportional to the amount present. That's always that really key phrase on these problems. Part A says, show that the constant of proportionality for the rate at which morphine leaves the body is negative 0.347. Now it's important to note that part A has nothing to do with the rate at which it's being added. So this 2.5 here is not going to factor into part A. In part A, we're simply looking at the half-life. So we have dq, which is our quantity, dt, equals kq is the situation we have in all of these because we're told that morphine is eliminated proportional to the amount present. So here we go. This is the rate at which it is changing. It equals kq. Since it's going down, you're welcome to put a negative there, or you can just know that k is going to be negative. All right, so when we solve this, we can do it the quick, easy way. Q equals q sub 0 e to the kt. So there we go. And we're asked to show that to find that k is negative 0.347. So we have to use as the information about the half-life. So let's just grab that information up here. We're told that the half-life is 2 hours. So we're going to use that information. And that means that if I start with 1, after 2 hours, I'm going to be at half. So there's my starting value, 1. I ending with half, and e to the k, and I'm told that that's going to happen in 2 hours. So in the place of t, I put 2. So then I'm going to take the natural log of both sides. Natural log of 1/2 equals 2k, and I simply solve natural log 1/2 over 2. And you will notice that if you divide this out on your calculator, that is going to equal 0.347. And this works just fine because we had said it was going to be a negative k. So there we go. So I guess since k is down here is negative, I better keep this positive up here. All right, so we're ready for part B. Now part B asks for a differential equation for the quantity Q of morphine in the blood after T hours. Now in this situation is a little more complex because not only do we have the half-life, we're also adding it at a rate of 2.5 milligrams per hour. That means that dq dt equals 2.5 minus 0.347 t. All right, so this is the amount that's being added per hour, and this is the amount that's being subtracted per hour. And it's per hour because t is measured in hours. All right, so we've written our equation, and this one the rate of change has to do with the addition and subtraction being combined. Now in part C, we're asked to find the equilibrium solution. Well, an equilibrium solution is where we're stable, and that if we're stable, that means there's no change, and if there's no change, that means that dq dt equals 0. So we simply solve the equation for when does 2.5 minus 0.347 t equal 0. And so to do this, let's see, we're going to get that 2.5 on the other side, and we're going to divide by negative 0.347, and we get our answer that occurs in 7.2 hours. And basically that means once we hit 7.2 hours, what we're adding and what we're subtracting is the same amount, and so we have the same level in the body.